Good day, ma'am. Today we're going to be reporting about our output entitled A Multiple Linear Regression Model for Predicting Human Development Index of World Countries. This is going to be presented by yours truly, Jude Martin Grozen, together with Rennie Joyce Sandico. So, let's get started.
For Chapter 1, we have the introduction to the study, which covers background of the study, rationale, objectives, and definition of terms.
So, for the background of the study, let's begin with what is human development? To explain this further, we have a video over here, courtesy of United Nations Development Program, Human Development Reports, which tells something about this human development. This is just a brief video, so let's try to see it.
Human development is a concept of development that has to do with the creation and improving of living conditions, where people can develop their full potential, can have a long and healthy life, can have access to an appropriate education system, can develop their potential to the fullest and be productive in order to have the opportunity to live according to their needs and interests. Human development in this aspect is about expanding the choices people have to lead qualitative lives. It is exactly those people who should be in the center of development process. Thus, human development means the capability for a long and happy life, for a qualitative education, and participation in economy to lead a life with dignity. Furthermore, the development does not concentrate on the amount of money a person gets, but on how much is invested in people. For example, as we know, the money can be used for medicine purchase, but also for the purchase of narcotic substances. Money can be used for military equipment, but also for construction of schools. Human development fights inequalities and promotes a life with dignity for all people worldwide, regardless of their origin, gender, and skin color.
So, as what we have seen in the video, human development as a whole is difficult to measure since there are various factors that should be taken into consideration to ensure that it can actually reflect a region's overall progress. So, how do we do that? How do we measure human development? Let's see in the next slide.
The United Nations Development Program, or UNDP, a global development network advocating for change and connecting countries to knowledge, experience, and resources to help people build a better life, uses Human Development Index to assess the development of a country based on its people and their capabilities, not economic growth alone. Countries having HDI value less than 0.5 are considered to have low development. HDI value between 0.5 to 0.799 are considered to have medium development, and HDI value greater than 0.8 are considered to have high development.
So, despite the fact that Human Development Index's measurement is only limited to the three basic dimensions of life, that is, a long and healthy life, knowledge, and a decent standard of living, while it excludes aspects like human rights, participation, and discrimination, but when significant levels of these dimensions are achieved, the doors for participation towards development open up for all people.
Rationale. The researchers conducted this study for the reason that it will enable them to learn and explore various indicators used in assessing and quantifying a country's development, such as HDI, and to further understand the underlying factors contributing to the increase or decrease in those indicators. Nonetheless, they may as well be able to construct a simpler alternative formula in estimating a country's HDI through multiple linear regression based on the same variables that were used in its actual computation, but is linear in form, contrary to the true calculation, which uses the concept of geometric mean.
But take note that this formula will only be applied as long as certain conditions affecting the said variables remain constant. So for our objective, our study aims to determine if a country's human development index can be predicted through its life expectancy at birth, expected years of schooling, mean years of schooling, and gross national income per capita as of 2011 PPP dollars using multiple linear regression.
For our definition of terms, the following terms that will be used in this study are conceptually and operationally defined. Expected years of schooling is the number of years of schooling that a child of school entrance age can expect to receive if prevailing patterns of age-specific enrollment rates persist throughout the child's life. In this study, expected years of schooling is referred to as one of the independent variables being tested to affect the dependent variable, which is the Human Development Index. Gross national income per capita is the sum of value added by all resident producers plus any product taxes, less subsidies not included in the valuation of output, plus net receipts of primary income, compensation of employees and property income from abroad divided by mid-year population. In this study, gross national income per capita is referred to as one of the independent variables being tested to affect the dependent variable, which is the Human Development Index.
Next, we have Human Development Index, which is a summary measure of achievements in key dimensions of human development, which are a long and healthy life, access to knowledge, and a decent standard of living. So in our study, this is going to be our dependent variable, which will be predicted by our independent variables in this study. Next, we have life expectancy at birth. This is the average number of years that a newborn is expected to live if current mortality rates continue to apply. In our study, it is going to be one of the independent variables that will predict our dependent variable Human Development Index. Next, we have mean years of schooling. This is the average number of years of education received by people ages 25 and older, converted from education attainment levels using official durations of each level. Notice that we also have expected years of schooling. Well, both of these are distinct from each other since expected years of schooling refers to the expected number of years of schooling of a child, contrary to the mean years of schooling, which refers to the average number of years of education received by people ages 25 and older. So in our study here, this is also one of the independent variables that will predict our dependent variable Human Development Index.
For Chapter 2, we have review of related literature. Literature about our dependent variable, which is Human Development Index, contains its definition, components, and human development reports, which tell what countries have highest and lowest HDI value. While literature about our independent variables, which are life expectancy at birth, expected years of schooling, and gross national income per capita, contains the respective definitions and recent information about the said topics.
Now let's proceed with our Chapter 3 methodology. Here we have the data gathering, we're checking correlations among variables, fitting the multiple linear regression model, and hypothesis testing.
For data gathering, we have a sample size of 126 world countries. The sampling method that we use is systematic random sampling, and as said earlier, our independent variables are life expectancy at birth, expected years of schooling, mean years of schooling, and gross national income per capita as of 2011 purchasing power parity dollars for the year 2014. Our dependent variable is Human Development Index or HDI, and our data source is from United Nations Development Program Human Development Reports website, and the link is projected on your screen.
Now, let's talk about the next step, which is checking correlations among variables. So what we basically did here is after the data has been gathered, the relationships between the dependent variable HDI and the independent variables life expectancy at birth, expected years of schooling, mean years of schooling, and GNI per capita were determined using Pearson correlation coefficient using SPSS version 16.
Our next step is fitting the multiple linear regression model. So our model is y is equal to beta sub 0 plus beta sub 1 times x sub 1 plus beta sub 2 times x sub 2 plus beta sub 3 times x sub 3 plus beta sub 4 times x sub 4 plus epsilon, where y is our Human Development Index or HDI, beta sub I are the coefficients, I ranges from 0 to 4, x sub 1 is our life expectancy at birth measured in years, x sub 2 is our expected years of schooling, x sub 3 is our mean years of schooling, x sub 4 is our GNI per capita 2011 PPP dollars, and our epsilon, which is our error term.
So lastly, we have the hypothesis testing, where we determine whether the independent variables are significant predictors of our dependent variable HDI, and the following hypotheses, which will be shown later, are going to be tested at the level of significance alpha equals 0.05. So here they are. So for the correlations between the independent variables and the HDI, we have the null hypothesis, which is there is no linear association between the independent variable and HDI. Then we also have the alternative hypothesis, which is there is a linear association between the independent variable and HDI. Next, we will proceed over our multiple regression model, which we have the null hypothesis over here, which is the model is not appropriate in predicting the HDI, and the alternative is the model is appropriate in predicting the HDI. Take note that these null hypotheses will be rejected whenever their p-values are less than the alpha, which is 0.05.
For chapter 4, we have results and discussion. So this chapter includes correlations, multiple linear regression analysis, and model fitting.
Now let's go over our correlations over here, and in this table we can see the correlations among the variables used in our study. So let's try to focus first on this first row, where we can see that the correlations between the independent variables, life expectancy at birth, expected years of schooling, mean years of schooling, GNI per capita, versus our dependent variable, Human Development Index. We can see here that the greatest correlation was found between the mean years of schooling and the HDI, where we have an R value of 0.916. And we also have the lowest correlation which is found between the GNI per capita and the HDI, where we have an R value of 0.785. It is also worth noting that all our p values are less than 0.05 since they are all 0.00, which means that all our independent variables show a linear association with our dependent variable HDI. Now let's try to focus on this part here. Yes, on this part over here, where we determine whether the independent variables themselves have a multicollinearity, or other way of saying is that if there exists a multicollinearity among the independent variables. So as what we can see here, all the p values are less than 0.05, which means that the correlations are very significant. But we can see here that the R values range from 0.650 to 0.839, which means that the correlations among these independent variables are just average. So we we can say that there is not much multicollinearity found among these independent variables, which is pretty good because we don't want to see any multicollinearity existing among our independent variables. So let's go to the next part.
Next is our multiple linear regression analysis and model fitting. So we have two tables here labeled model summary and ANOVA table. So let's focus first on the model summary. We can see here that we have a value of 0.976 for our R-square, which means that 97.60% of the variability in the Human Development Index is explained by the variability of our independent variables, which are gross national income per capita, mean years of schooling, life expectancy at birth, and expected years of schooling. Let's proceed to our table number 2, which is the ANOVA table. As what we can see here, we have an F value of 1,238.74 and a P value of 0.00, which is less than the value of our alpha, which is equal to 0.05. This means that our model is appropriate in predicting the Human Development Index.
Now let's proceed to our coefficients of our multiple regression equation, which is shown in this table. So we have a coefficient for a constant, which is negative 0.78, which has a p-value of 0.002. So it's not that bad. It's still significant. And we also have our coefficient for our life expectancy at birth, which is 0.006. Our coefficient for expected years of schooling, which is 0.012. Our coefficient for mean years of schooling, which is 0.018. And we also have our coefficient for GNI per capita, which is 1.6 times 10 raised to the negative 6. And we can see that all their p-values are equal to 0.000. So all of our coefficients are definitely significant.
Hence, a country's Human Development Index is predicted by the following multiple regression equation. Y hat is equal to negative 0.078 plus 0.006 x sub 1 plus 0.012 x sub 2 plus 0.018 x sub 3 plus 1.600 times 10 raised to negative 6 x sub 4, where Y hat is our Human Development Index or HDI, X sub 1 is the life expectancy at birth measured in years, X sub 2 is the expected years of schooling, X sub 3 is the mean years of schooling, and X sub 4 is the gross national income per capita 2011 PPP dollars. So the equation says that a country's predicted Human Development Index is increased by 0.006 for every year increase in its life expectancy at birth, increased by 0.012 for every increase in its expected years of schooling, increased by 0.018 for every year increase in its mean years of schooling, and increased by 1.600 times 10 raised to negative 6 for every dollar increase in its GNI per capita 2011 PPP dollars. Constant was not interpreted since it is impossible for a country to have zero values in all the independent variables of the equation.
Chapter 5, Concluding Remarks.
This study was conducted to figure whether or not a country's Human Development Index can be predicted by its life expectancy at birth, expected years of schooling, mean years of schooling, and gross national income per capita 2011 PPP dollars using multiple linear regression.
After the data has been gathered, SPSS version 16 was used to analyze the said data. The results showed that all the independent variables, namely life expectancy at birth, expected years of schooling, mean years of schooling, and GNI per capita, are significant predictors of the independent variable HDI, which is predicted by y hat is equal to negative 0.078 plus 0.006 x sub 1 plus 0.012 x sub 2 plus 0.018 x sub 3 plus 1.6 times 10 raised to the negative 6 x sub 4, where y hat is the human development index, x sub 1 is the life expectancy at birth in years, x sub 2 is the expected years of schooling, x sub 3 is the mean years of schooling, and x sub 4 is the GNI per capita for 2011 PPP dollars, with F of 4,121 equals 1,238.74 and P value of 0.000.
It is suggested that future researchers predict similar indicators associated with development and standard of living, such as multidimensional poverty index, employment rate, and gender development index.
So that concludes our presentation. Please don't forget to send us your feedbacks regarding our presentation.
Thanks for watching!